Okay, here is example number 3 from section 14.5. It says here that we have a 50-foot ladder. It is placed against a large building. The base of the ladder is resting on an oil spill and it slips to the right of the figure at the rate of 3 feet per second. Find the rate of change at the height of the top of the ladder above the ground at the instant when the base of the ladder is 30 feet from the base of the building. Read that one more time if you need to. You have a 50-foot ladder. It slides away. It slides away at a certain rate. We want to find the rate at which the height of the top of the ladder hits the ground, pretty much. Okay? So they gave us a picture here, but they're not always going to give you a picture. So if I didn't give you that picture, would you still be able to kind of draw that same scenario? Okay? So it looks like here we have a 50-foot ladder. Now that ladder is always going to be 50. It's never going to change sizes. It's always going to be a 50-foot ladder. I'm going to call this side down here X, but as that ladder slides, isn't that X going to change? And so X is going to have a rate of change as time goes on. Can I call that dx dt? Y, I called this piece Y, and Y is going to change, right? As that ladder slides down the building, there is going to be a rate of change in that amount, that distance. Can I call that dy dt? And then it says a few other things. It says here, when the base of the ladder is 30 feet from the base of the building. When the base of the ladder is 30 feet from the base of the building, to me, that means that X is the 30 feet. Okay? So when X is 30, and the ladder is always going to be 50, and I have a right triangle here, because I'm going to assume the ground is flat and the building is straight up and down, how would I find Y? Well, can I use Pythagorean theorem? We know that anytime we have a right triangle, we can say that a squared plus b squared equals c squared. So off to the side, I should be able to do 30 squared plus y squared equals 50 squared, and I should be able to figure out what y equals. At the exact moment that x is 30, then I should be able to figure out that y is going to be 40. So I have a couple givens here. I have that x is 30. I have now y is 40. I want to find the rate at which the height of the ladder is dropping down. Don't I want to find then dy dt, how fast the ladder is sliding down that building? But what else does it say in my problem? Doesn't it say that the base of the ladder slips at a rate of? And if we called the base of the ladder that distance x, and it changes at a rate of, isn't that my dx dt? So I'm going to say that dx dt is equal to 3 feet per second. So I have a couple givens here. Remember, my next step is to look for a formula. Is there some sort of formula that relates all of this stuff together? So we're talking about a couple things here. We have a ladder, we have this distance changing, and we have this distance changing. Now in our last problem, we were talking about area. But this question isn't really talking about the area change. It's really talking about how these sides are going to change as the ladder falls. And it happens to be sides of a right triangle. And so what formula or equation do we have that relates sides of right triangles together? Well, like we used over here, Pythagorean theorem, right? Don't we know always anytime we have a right triangle that we can say that the side squared plus the other side squared equals the hypotenuse squared all the time? And that's how the sides are related to each other. So I can use Pythagorean theorem, x squared plus y squared equals 50 squared, to relate all this stuff together. Do you see how I used x as a variable because that's going to change? And y is still a variable because that amount is going to change? But do you notice that I kept the 50 there? Because isn't that 50 never going to change? That 50 is always going to be a 50-foot ladder, so he's not going to have a rate of change. Or really his rate of change is going to be 0 because he's always going to stay the same. He's not going to have a rate of change. So be careful on that one. Don't start plugging things in if things are going to change. That's why I kept the x and I kept the y. So now my third step is to find the rate at which all this stuff changes over time. The derivative. I want to find the derivative with respect to time. So the derivative of x squared is 2x dx dt. the derivative of y squared is 2y dy dt, and the derivative of any constant, whatever 50 squared is always 0. So we have a few things, don't we, from the givens? We should know what x is, we should know what dx dt is, we should know what y is because we found that to be 40, and we're trying to figure out what dy dt is. So hopefully we have all the variables except for one so that we can solve for dy dt. So I plugged everything in, and I solved for dy dt. You should end up getting negative 2.25. Wait a second. Does negative 2.25 make sense? Well, let's stop for a second and let's think about what we were actually finding. We were finding dy dt. And in our scenario, dy dt was the rate at which this was changing. Oh, so if the ladder falls down the wall, isn't that distance going to get smaller because the ladder is going to fall down? So it should make sense that dy dt is negative because that's going to get smaller, where dx dt is going to get bigger because the ladder is sliding away and that amount is going to get larger, right? X is going to get bigger. That's why that was positive 3. And so negative 2.5 should make sense. So let's make a sentence. When is it happening? What's happening? And what's your answer with correct units? Well, when the ladder is 30 feet from the base, dy dt, which remember is the height is decreasing at a rate of 2.25 feet per second. When the ladder is 30 feet from the base, the height is decreasing at a rate of 2.25 feet per second. Pretty cool, huh? All right, I'll make another video for example number